Hello there. Today we're going to go over combining direct and inverse variation. First thing are variation combinations. On this equation, you have direct and inverse combined. Your equation z equals kx over y. So the x is on the top of the fraction, which means k is being multiplied by x. That's the direct. So if k is 200, it's 200 times whatever x is. But there's also y at the bottom of the fraction. So y is inversely related to z because you can see that the right side is being divided by y. So whatever number k is, it's being divided by y. That's inverse. And then we say z varies directly with x and inversely with y. Now that could be, I wrote that equation two ways. Sometimes you see k on top of the fraction. Sometimes you see it out in front of the x over y. All right. So here's some examples. So set up an equation. E varies directly with m and inversely with c. Okay. So I'm going to copy this little template I made here. A little smaller. Okay, so E varies directly with M and inversely with C. So E is going to be on the left side of the fraction, the left side of the equals. And then there could be a K out front, so we're going to put a K out front there. And then varies directly with M, so M's on top of the fraction. Capital M there. And inversely with C, so C is on the bottom of the fraction. Now the K could be up top, at the top of the fraction instead of front, but it's going to be the same thing. There it is. E varies directly with M and inversely with C. All right. See if you can get the next one. So try that. Pause your video if you need to. I'm going to write it down now. Let me get my little template thing here again. Okay, so Z varies, so it's going to be Z, varies directly with Q, so that's on top of the fraction. I'm going to put a K, I'm going to put my K on top of the fraction. Directly with Q, K times Q, and inversely with C. C's on the bottom of the fraction. That's how you rate these. All right, so an example of this is Ohm's law. So you have current I, voltage V, and resistance R. So the current I is directly proportional to V and inversely proportional to R. So this is a real equation used for electric. So this is the equation. So I varies directly with V, so it's on top of the fraction, inversely with R. Now there's no K on this. Well, you could say K is 1, but the equations, this is the equation. So let's see what happens when current I, when V stays the same, but R is increased. So if the R goes up, now this is an inverse relationship because R is on the bottom of the fraction. If R goes up, then I goes down, decreased. It's inverse. Now let's see why this works. Well, one reason I and R have an inverse relationship. You could just say that for justification. But let me show you why with some numbers. Let's say we have this. I'm going to copy and paste here a little bit. Actually, use that. Let me see here. Let me see. Copy this a few times. Okay. So let's say V was 1,000. I don't know if there's actually 1,000, a voltage of 1,000, but I'm using 1,000. All right, so we're going to do a couple examples here. Okay, let's say the R is 1. So what's 1,000 divided by 1? It should be 1,000. Right? So that would be, the I would be 1,000. Now let's say we had the R is 10. So 1,000 divided by 10, 100. Let's say that the R is 100. I'm just using numbers that I would multiply by 10 because it looks easier for you. Again, I don't think there's a voltage of 100. Maybe there is. Okay, so if it's 1,000 divided by 100, I would be 10. And you could keep going and going. But if you divide it by 1,000, I would be 1. Okay, so as you can see, as R goes up from 1, 10, 100, 1,000, I goes down because this number is being divided by a bigger number. So that's why. Okay, let's take a look at this one. V stays the same. Oops, we just did that one, right? Okay, so we did this one. What happens to current I when R stays the same and B is increased? So what V is going to be, it's going to be basically, it's not multiplied by a K because there's really no K there, but it's going to make the number bigger because it's on top of the fraction. If the number on the top of the fraction is bigger, then I is going to be bigger. So let me show you why again. R stays the same and V increased, then I increases. Okay, so that's what happens. Let's see why again. Let's organize this. Good. Okay, let's say that R stays the same. Let's say R is, let's say 5. Okay. And I'm going to copy some of these. Bear with me here. Okay, so let's say R staying the same, it's 5 every time. Let's say V is, let's say V is 5. Okay, so you know 5 divided by 5, 1. And let's say V is 50. Going up. So V is going up. 50 divided by 5 is 10. And let's say V is 500. You probably got the point by now, but I'm going to keep going. 500 divided by 5 is 100. Right, so V is going up, I is going up. And then we go to 5,000. 5,000 divided by 5,000. Okay, and all that is just to demonstrate to you that there's a direct relationship. When V goes up, I goes up because V is on top of the fraction. Okay. So I'm going to leave these notes on your assignment so that you can take a look at them. Okay, now the next one, this is part of the homework, so make sure you write this down on your homework. I'm going to go over the first 2 questions. So here's an equation. You have Z equals KX Y. Now, it seems kind of long. Some people get confused by this. All it's saying here is that these numbers are all positive. If there was a negative, it would be a different relationship, but we're not going into that. So all those numbers are positive. How will Z change if X is this held constant and Y increases? Well, let's see here. Okay. So X is held constant, Y increase. Now there's no fraction there. These are being multiplied. So if X is held constant, Y increases, then Z increases. And why? You have to write that on your homework because there is a direct relationship from Z to Y. That's one way you can write it. You can write it many different ways, but just so you say that that's a direct relationship. All right. So y goes up, z goes up. Now, what if x is held constant and y decreases? The y goes down. It gets smaller. It's being multiplied by a smaller number. So z decreases. Yep. And the justification is the same here. Because there is a direct relationship from z to y. Okay, so that's the first part of your homework. And the next part has a fraction. Now, you know when there's a fraction, that means what's below the fraction is going to be inverse. Okay, so that is the lesson. And make sure you come into the Zoom and ask us any questions you have. Okay, have a good day.